Hello students, how are you all? Fine, doing great. So, I am here to explain about the practical syllabus of semester 3 students. It's almost time we should start the practical. So, all these days we have been doing the theory syllabus. So, I should do simultaneously the practical syllabus also. So, what I will do is, I will explain the principle, experiment and all. Later we will look into the experiment part. Okay. So, if God permits, if we meet in the college, then we will do the experiment part. But prior to that, I will complete the explanation of all the experiments, that is, all the experiments not in this video, one by one I will be doing. Ready? Okay, so now, last year, do you remember what was the practical that we have done, students? Do you remember? First semester, so with so much of fear entering into chemistry labs, some must be so much excited, like buying the aprons, looking at the apparatus, because many of you might have not done the practicals during your intermediate level, right? So with so much of fear, that means you are scared of chemistry, right? So, but later, after few weeks, I think you must have understood the experiments, you must have understood the practicals, and most of you might have enjoyed the lab also. Right? Am I right, students? Okay. So, what was the practical that we have done last year, students? That is in your first year, BSc first year. What did you do? Do you remember? So, in the first semester, you have identified the anions. In the second semester, you have identified both anions and cations. Do you remember the name of that practical, students? Yes, it is a semi-micro analysis. So, when a mixture of salts was given, what did you do? You have done few tests and checked for the presence of different anions and cations. Okay, so that is a semi-micro analysis which comes under qualitative analysis. Okay, so analytical chemistry is briefly classified into qualitative analysis and quantitative analysis. So what is the difference between qualitative analysis and quantitative analysis, students? See, we have given in the labs, we have given the salt mixture, that is mixture of two salts. Then you have done few experiments and identified running to, you will be running to the staff members. Ma'am, this is carbonate. Ma'am, this is that. This is this. Ma'am, I have observed this color. Ma'am, I got this PPT. So like that, you have identified various anions. So the presence of anions and cations you have identified. So that is called as qualitative analysis. Okay. So we have determined or identified the constituents present in the salt mixture. Okay. So now this year, second year, you are going to do quantitative analysis. Qualitative means what are the constituents present in the mixture. Quantitative analysis means we are going to determine the amount of the substance present in the given solution. Okay, so that is quantity, and that is first year, that was a qualitative analysis. And students, one more thing I want to remind you, this theory of quantitative analysis you have already studied in your first year, that is in general chemistry, you have done it. So now doing the experiments and learning the experiments under quantitative analysis will be very easy for you. My sincere suggestion is take the books of first year and kindly refer to quantitative analysis once. Okay, then what I am explaining now will be easy for you. Okay, students, right? So the practical that we are going to do in second year is called as quantitative analysis. Is nothing but determination of amount of the constituents present in the given solution. Okay. Now this quantitative analysis can be divided into how many types? Two types. What are they? Volumetric analysis and gravimetric analysis. Okay. So first we will be doing volumetric analysis. At the end of the year we will be showing you the gravimetric analysis. Okay. So both come under quantitative analysis only. But what is the difference between volumetric and gravimetric, students? Both the analysis we find the amount of the substance, but under volumetric analysis we find the amount of the substance by measuring the volume of the solution. Okay, whereas under gravimetric we will know the amount of the substance by weighing the substance. Okay, so we will worry about gravimetric analysis later. First we will look into volumetric analysis. Under volumetric analysis, students, we have the following types of titrations. Look here, I have mentioned what is AB titrations, acid-base titrations, complexometric titrations, redox titrations and precipitation titrations. Okay, so in third semester, that is semester 3, we will be having acid-base and complexometric titrations. In semester 4, we will be doing redox and precipitation titrations. Okay, so in this video, I will be doing the first acid-base titration. Okay, so kindly maintain one observation notebook for your practical. And in the first page, please write down, put the heading as quantitative analysis and divided into volumetric, gravimetric, and under volumetric we will be having these 4 types of titrations. Okay, so let's start with the acid-base titrations. Put the heading acid-base titrations. Acid-base titrations. So the first experiment under acid-base titrations in your semester 3 syllabus is estimation of sodium bicarbonate. Estimation of sodium bicarbonate. Put the heading, students. Estimation of sodium bicarbonate. Okay. So you have to write all this theoretical part in your observation notebook. It is mandatory. Okay. Now, so under this, put the side heading aim. Okay. So we know we will be having aim, principle and procedure. Later we will be doing the calculations after doing the experiment. Okay, students, ready? Write down. Aim. To estimate the amount of sodium bicarbonate. What is the formula of sodium bicarbonate, students? NaHCO3. To estimate the amount of NaHCO3 present in the given solution. Okay? Full stop. Next comes, next side heading, principle. Next side heading, principle. Write down NaHCO3 reacts with HCl and the neutralization point. Look here students, I am writing the spelling. Neutralization point can be detected by using look here students, methyl orange indicator. Methyl orange indicator. Full stop. Written students. NaHCO3 reacts with the HCl and the neutralization point can be detected using methyl orange indicator. Below write down the reaction. NaHCO3 plus HCl gives rise to NaCl plus H2O plus CO2. Okay. So, in this reaction, NaHCO3 is a base and HCl is the acid. Hydrochloric acid and sodium bicarbonate. Okay. So, this is under acid-base titration. Okay. So, what are we getting students? NaHCO3 plus HCl gives rise to NaCl plus H2O plus CO2. Okay. Written the reaction. Below write down. HCl can be standardized. HCl can be standardized. I will be telling you about all these, what standardization is, what an indicator is, all this, don't worry. Okay. HCl can be standardized by titrating, titrating against standard sodium carbonate, against standard sodium carbonate and the unknown sodium bicarbonate and the unknown sodium bicarbonate can be estimated using standardized HCl. Full stop. What is our experiment students? What is the aim of the experiment? To estimate the amount of NaHCO3 present in the given unknown solution. Okay. So what is the principle? NaHCO3 reacts with HCl and the endpoint can be detected using an indicator called as methyl orange indicator. Okay. Now, how is the experiment done? HCl can be standardized by using standard Na2CO3, that is sodium carbonate, and the unknown sodium bicarbonate. The amount of sodium bicarbonate is to be determined. That unknown sodium bicarbonate solution can be estimated. The amount of NaHCO3 can be estimated using standardized HCl. How this HCl is standardized? Using standard Na2CO3. Okay. So what is the experiment? Estimation of NaHCO3. But for that we are using standard Na2CO3. What is this standard Na2CO3 students? This is called as a primary standard substance. There are two types of standard substance, primary and secondary. What is the difference between primary standard and secondary standard? Primary standard substance can be, that is the standard solution is the solution whose concentration is known, and even after few days also its concentration remains constant. Okay, whereas a secondary standard substance, its concentration changes when time passes. Okay, that means the concentration of a secondary standard substance or secondary standard solution is not known. Therefore, what we do, we will know the concentration of a secondary standard solution using a primary standard solution. Okay, so underline that standard Na2CO3. Mostly in Viva, you will be asked what is a primary standard substance, whose concentration is known and whose concentration doesn't change even after few days. Okay, so here standard Na2CO3 is the primary standard substance being used for the estimation of unknown NaHCO3, and HCl is also a secondary standard substance. Okay, so in order to know the amount of NaHCO3, we use HCl, but HCl is a secondary standard substance. So how is its concentration known? Using standard Na2CO3. Okay students, now you understood? Primary standard substance taken in this experiment is Na2CO3. With the help of its concentration, we will know the concentration of HCl. Okay. Now, from the concentration of HCl, we will determine the amount of unknown NaHCO3. This much is there in these two sentences. Got it? Next. So, below write down the reaction. Na2CO3 plus HCl gives NaCl plus H2O plus CO2. Okay. So here this is not balanced. So you will be taking Na2CO3 plus 2HCl. Plus 2HCl gives 2NaCl plus H2O plus CO2. Okay students. See, to standardize or to know the concentration of HCl, we are using primary standard sodium carbonate. Okay. Now the concentration of HCl is known. So using this standardized HCl, we will know the amount of unknown NaHCO3. Got it students? Am I clear? Okay. So below write down here, left corner, indicator, write down methyl orange, indicator methyl orange, and end point yellow to pink. End point yellow to pink. Okay, so we should stop the titration when the solution turns into pink color. Okay, so that's what we say in the beginning. Immediately after the indicator is added, solution turns yellow in color. After the reaction is completed, the solution turns to pink color. Okay, so this all comes under AIM principle. Okay students, clear? So let's write down. Now let's write down the procedure. Put the side heading procedure. So step 1 under procedure. Put the side heading. Step 1. Preparation of standard sodium carbonate solution. Preparation of standard sodium carbonate solution. Okay, underline students, underline. Write down. Weigh about 1.325 grams of Na2CO3, dissolve it in distilled water, in a 250 ml standard flask, make up the volume, make up the volume, make up the volume to the mark, comma, shake well, and calculate the molarity of Na2CO3. Calculate the molarity of Na2CO3. Okay. So here we will be finding the concentration of Na2CO3. Okay. So that is your first step, students. What is that? Preparation of a standard Na2CO3 solution. So how is this solution prepared, students? See, look here. What is given in the procedure? Weigh about 1.325 grams of Na2CO3. Where will we weigh? And how will we weigh that substance, that amount of the substance? Okay, so Na2CO3 will be given to you. There will be an electronic balance and the substance from the bottle should be taken using the spatula. Can you see? This is called as a spatula into the weighing bottle. This is called as weighing bottle. Okay. So we should not rinse this weighing bottle with water. So what should be done? Just take a filter paper like this. Okay. So just wipe inside the weighing bottle with the paper. So make sure that this is clean. Okay. Then you will be taking the substance into this bottle and you should weigh the substance. How much should be taken? 1.325 grams. Okay. So as we are doing it on the electronic balance, weighing will be easy than on a common balance. Okay. This is what is called, students. This is called as weighing bottle. Okay. So take the substance from the sodium carbonate bottle with the spatula and weigh. If some is extra, then remove the substance with the spatula only. If some extra is needed, add the substance with the spatula only. Okay, fine. So this is your weighing bottle. What is to be done? Weigh 1.325 grams of Na2CO3 and this substance, students, this substance which you have weighed in the weighing bottle, it should be now transferred into a 250 ml volumetric flask. Okay. So this is the volumetric flask. I have with me a 100 ml flask, but according to the experiment, according to the weight taken, we should use a 250 ml volumetric flask. It will be slightly bigger than this. This is a 100 ml volumetric flask. Okay. So now after weighing the substance, you just remove the stopper and place a funnel over it. This is the funnel. Okay. Place the funnel over it and carefully transfer the substance through this funnel into this volumetric flask. Okay. So one bad habit generally we will be having. Okay. What is that bad habit? You know, students, all the substance will not come from this weighing bottle into this funnel. So what we do? Immediately, the bad habit that we have is, see, we use the finger and we will try to remove the substance from the weighing bottle. But we should never do that. Okay, students, never do that. Okay, if the substance is left behind in the weighing bottle, let it be. Fine. So, from this weighing bottle, transfer the substance into the volumetric flask through the funnel. Carefully keep aside, before keeping aside, what you should do, some substance will be there on the walls of the funnel. So what you should do, take the wash bottle having distilled water and slowly rinse this walls of the funnel. Okay, slowly some water, when you add here the substance which is there on the walls, it comes down into the flask. Okay, now keep this funnel aside. So some water is there na, so try to shake this flask. Okay, try to dissolve the substance in little amount of water first. Don't pour complete this full flask full of water and then try to dissolve. No, some water, try to dissolve the substance. Then you should make up the volume to the mark, students. Okay, can you see the mark here, students? There is a mark over here. What is it written in the procedure? Make up the volume to the mark. Slowly till here you can add with a wash bottle. Later you should be using a pipette to make up the volume. What is a pipette, students? So this is the pipette. Okay, and one more thing you should remember, students, before using the apparatus you should clean the apparatus thoroughly. First with tap water and then with the distilled water. Okay, so slowly you will be sucking the water from the wash bottle using this pipette. Okay, so after you suck the water, you will close with your thumb. Okay, so then you can drop slowly, drop by drop into this volumetric flask to make up the volume. Okay, slowly when you are almost near the mark, you should be very careful. Okay, so and also one more thing, if the solution is colorless, you should check for the lower meniscus. What is lower meniscus, students? See, lower meniscus is this. Okay, you should check for this lower meniscus. If it is a colored solution, then you will check for the upper meniscus. So this is the mark on the flask. Colorless solution, check for the lower meniscus. Colored solution, check for the upper meniscus. Okay, students, clear? Clear, students? And also one more thing, after dropping water, don't try to blow the air through this pipette. Okay, so these are all the bad habits that should be avoided in a chemistry laboratory. Okay, so we are all chemists. We are doing chemistry experiment. So we should behave decently and try to know before using the apparatus. Okay, so you should not use the apparatus as you like. Understood, students? Fine. So that means, so when you have added water till here, then you should close this volumetric flask. In case by mistake, suppose the lower meniscus is a little above the mark, don't try to discard the solution. Okay, don't try to discard the solution. Let it be. Next experiment, you will be doing it carefully. In the beginning, it will be little difficult. Later, you will be get used to the experiments. Okay, students, that is your first step. Fine. So next, step 2, students, standardization of HCl. Standardization of HCl. Underline the side heading. Please write down the procedure. Pipette out. Pipette out 20 ml of pipette out 20 ml of standard Na2CO3 solution. 20 ml of standard Na2CO3 solution in a clean conical flask. In a clean conical flask, comma, add 1 test tube of water, add 1 test tube of water, comma, 2 to 3 drops of indicator. You know the indicator used in this experiment? Methyl orange. 2 to 3 drops of indicator, comma, titrate against HCl taken in the burette till the color changes from yellow to pink. Till the color changes from yellow to pink. Full stop. Repeat the titration and calculate molarity of HCl Okay, so what is to be done in this procedure, students? So this is a standard Na2CO3 solution. Okay, so what is to be done? Carefully pipette out 20 ml of this solution. So how will you know 20 ml how to pipette out? Look here, I have shown you the pipette, right? This is a 10 ml pipette. Students, this also has a mark. Same rule for this also. Colored solution, upper meniscus. Colorless solution, lower meniscus. Okay, so slowly we will pipette out the solution till here where the mark is present. Okay, so 20 ml, so I will be given 20 ml pipettes. So slowly we will pipette the solution from this volumetric flask using your mouth and slowly close the upper side of the pipette with your thumb. Okay, if some extra is there, slowly release the thumb and drop the solution into this. Okay, so carefully till the mark the solution should be there, students. Fine. Now, so close this with the thumb and you will drop this solution where? Into a clean conical flask. Okay. So this is your conical flask. Okay. So you will drop the solution into, can you see this, students? Can you see this? Right. So drop the solution by releasing the thumb. Don't blow the last drop with your mouth. Okay. Now keep the pipette aside. And what should be done, students? 1 test tube of water. I need not show you the test tube. Okay. 1 test tube of water into this solution. Next, 2 to 3 drops of methyl orange indicator. So immediately after adding methyl orange indicator, the solution turns into yellow color. Okay. So what you should be done? Now what should be done, students? See, now the amount of the solution, that is standard Na2CO3, which is a primary standard substance whose concentration is known, the amount, the volume of the solution is also known. How much is taken? 20 ml. Okay, so this is called as a titrant which is present in the conical flask. Now, what should be done? It should be titrated against HCl. HCl taken in the burette. Students, look here. This is the burette. We cannot simply hold like this. There will be a burette stand for this. We will fix the burette to the stand. Okay. And here also the same, students. There will be this is a 10 ml burette, students. Generally we will be giving you 50 ml burettes. So 50 ml we will fill the HCl solution. Because we don't know how much volume of HCl is required to neutralize Na2CO3. Okay, so we will fill up to the mark, and what we do, we will fix this burette to the stand, and below we will put the conical flask. Okay, and slowly what we will do, we will release like this. Okay, drop by drop we will release HCl where not into the air. There will be the conical flask here. Okay, so slowly what we will do, students? So when drop by drop is coming down from the burette, we will slowly titrate the solution present in the conical flask. Now HCl starts reacting with the Na2CO3. Okay, so HCl starts reacting with Na2CO3. Now we don't know when the reaction is completed. That means when HCl and Na2CO3 they are neutralized. That means when the end point is reached. We cannot know by seeing simply the solutions, right? So for that we need an indicator. Okay, so indicator, when it turns pink in color, we will be knowing that the reaction is completed and also neutralization point is reached. Okay, understood students? Hope I made clear showing you this apparatus. Okay, so when the yellow solution turns pink in color, slowly you stop this, okay, and check for the reading on the burette. So you should remove the burette from the stand and don't try to look like this, keeping this keeping this burette fixed to the stand. Don't look at the reading on the burette. Kindly remove the burette from the stand and check for the reading. How much ml is 4 ml or 5 ml or 10 ml, 20 ml is used for neutralizing Na2CO3. Okay students, so what you do, you should note down the reading. So here what is given, repeat the titration. That means for example, first time you got 4.5. Second time also you should get 4.5. Suppose you get second time 4.8. Third time also you should repeat, because 2 times you should get the concurrent values, that is the same value you should be getting. Okay, that's why we say repeat the titration to avoid errors. Okay, so with this volume of HCl used, we can calculate concentrate, that is molarity of HCl. That's what your second step is. Let's move on to the third step. Put the side heading. Step 3, estimation of unknown sodium bicarbonate, that is NaHCO3. Underline students. Write down the procedure. Pipette out 20 ml of the given unknown NaHCO3 solution. The given unknown NaHCO3 solution into a clean conical flask. Comma, add 1 test tube of water. Comma, 2 to 3 drops of indicator. Comma, titrate against HCl taken in the burette till the color changes from yellow to pink. Full stop. Repeat the titration and calculate the molarity of NaHCO3. Calculate the molarity of NaHCO3. Students, the unknown solution will be given in the beakers like this. Okay, and HCl also you will be getting in a beaker like this only. From the beaker you will be filling the solution into the burette. The unknown will be given in the small beaker. Okay, fine. So from this you will be pipetting out. Same students like the second step. There you are taking standard Na2CO3 in the conical flask. In third step you will be taking 20 ml of unknown NaHCO3 solution into the conical flask. Same procedure like step 2. Okay, so this is the procedure for your experiment. Next, what should be done? We should note down the values and calculate. Okay, for that we need tables, right? Next, put the side heading observations and calculations. What is it, students? Observations and calculations. So write down, students, observations and calculations. Step 1. Step 1. Weight of empty weighing bottle. So before taking 1.325 grams of substance, we should know the weight of the empty weighing bottle. Okay. So weight of empty weighing bottle, comma, W1 is equal to dash grams. Next, weight of a bottle plus Na2CO3. How much will you take? 1.325 grams. Okay. So weight of the bottle plus Na2CO3 1.325 grams, comma, the total weight will be W2 is equal to dash grams. Below, weight of the bottle after transferring the substance. Okay. I told you that the substance should be transferred into the volumetric flask. Okay. So after transferring the substance, you will again go back and weigh the bottle, that is W3. Next, weight of the substance transferred into the volumetric flask. Weight of the substance transferred into the volumetric flask. So how will we get that weight, students? So from the total weight, that is bottle weight plus substance weight, W2 minus W3. If something is left behind in the weighing bottle, so if we subtract these two values, we will be getting the weight of the actual amount of the substance transferred into the volumetric flask. That is denoted by W2 minus W3. Understood? Next, therefore, molarity of Na2CO3 is equal to weight by liter into molecular weight. That liter also will be in the denominator, students. Okay. So it is equal to, clearly write down below, weight by molecular weight into 1000 by 250. Why are we doing 1000 by 250? Because we have taken the substance in a 250 ml volumetric flask. Okay. So the formula is weight by liter into molecular weight. As we are taking in a 250 ml, 250 by 1000. So 1000 goes up. Right. So it is equal to weight of the substance. What is it? W2 minus W3 by 106, that is molecular weight of Na2CO3 into 1000 by 250. Okay. So substituting the values, you will get to know the molarity, that is concentration of Na2CO3 is equal to that value. Units you will be writing molar, capital M. That is the step 1's observations and calculations. So next, step 2, students. Step 2. Write down the reaction first. Na2CO3 plus 2HCl gives rise to 2NaCl plus H2O plus CO2. This reaction is very, very important for the calculation. Okay. So next comes the table. Draw neatly with a scale and pencil. Don't draw as you like. Okay. So observation. It should be maintained neatly, students. So first column, serial number. Next, volume of Na2CO3. Next, burette readings. Under burette readings, again divide into two columns. Initial, final. Final column, volume of HCl. Okay. So serial numbers 1, 2, 3. Write down, students. Volume of Na2CO3. We know that we have taken 20 ml. So 20 for all the three titrations. 20, 20, 20. Burette readings. Initial. You can note down it as a 0. If we fill the burette completely for all the three titrations, you can take initial reading as 0. So whatever reading you are getting at the end point, you will note down here. Suppose if it is 20.5, the same final minus initial will be volume of HCl 20.5. If it is 21, 21. If it is 22, 22. Okay, fine, understood now. Next, below comes the formula. So, it is acid-base titration, students. Na2CO3 versus HCl. So, the formula goes like this. M1V1 by N1 equals to M2V2 by N2. So, left side we have taken Na2CO3. Right side HCl. So, left side that means M1V1. N1 will be Na2CO3 values. M2V2 N2 will be HCl values. So, below write down. Molarity of Na2CO3 denoted by capital M1. This you will be getting from step 1, that is molarity of Na2CO3. Below, volume of Na2CO3 V1 we have taken 20 ml. Okay. Next, number of moles of Na2CO3, that is small letter n, N1 from the reaction, that is 1. Next, molarity of HCl M2, which is to be calculated. So, M2 is equal to question mark. Next, volume of HCl V2, we will be knowing it from the burette after doing the experiment. So, that's why I have written here, students, burette reading. Next, number of moles of HCl, that is N2 from the reaction. How many moles we have taken? 2 HCl. So, it will be equal to 2. Okay. So, now what should be calculated from this set of values? M2 is to be calculated. I will show you how to calculate M2. So, M2 is equal to M1 V1 N2 divided by N1 into V2. Okay. So, all the values you will be substituting in the formula, and final value you will be writing it as see, the units you should mention it as capital M, that is molarity units. Okay. Step 3, students. Write down the reaction first. Reaction is very, very important, students. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. Next comes the table. Serial number, volume of NaHCO3. Next, burette readings, initial, final. Next, volume of HCl. Okay. Same like the previous one, but here it is NaHCO3. Serial numbers 1, 2, 3. Volume of NaHCO3, how much we have taken, students, unknown? 20 ml. So, 20, 20 and 20. Burette readings, initial 0. So, depends upon the final reading, that will be the volume of HCl. Fine. Next, below write down NaHCO3 versus HCl. Reaction taking place between sodium bicarbonate and HCl. So, write down molarity of NaHCO3 denoted by capital M1 is equal to question mark. So, this is our experiment, estimation of NaHCO3. Next, volume of NaHCO3 denoted by V1, which is equal to 20 ml. Next, number of moles of NaHCO3 denoted by N1, use small letter N, students, is equal to 1 from the reaction. Next, molarity of HCl denoted by M2, that is from step 2. Step 2 is nothing but standardization of HCl. There we have determined concentration of HCl, students, that you will be using here. Next, volume of HCl denoted by V2, that will be the burette reading where the solution turns from yellow to pink. Next, number of moles of HCl, that is N2, it is equal to 1. Okay. Therefore, M1 is equal to, what is M1, students? Molarity of NaHCO3. M1 is equal to, from the formula, M2 V2 N1 by N2 into V1. Substituting the values, we can know the concentration or the molarity of NaHCO3. We will substitute here. Next, finally, we should know the amount of, I told you, volumetric analysis is knowing the amount of the substance by measuring the volume. Now, we have measured the volume till here we have done. Measuring the volume of HCl used to neutralize Na2CO3. Okay, finally, the amount of NaHCO3 present in the given unknown solution is equal to, how will we get, students? This molarity of NaHCO3 into molecular weight. So is equal to this step 3 value, how much ever value you get, into 84. So whatever value you get by multiplying these two terms, you will be writing here, and the units you are supposed to write grams per liter. Okay, so this is your first experiment, students. Hope you understood this experiment. Okay, so please listen to the video completely, then write down in your observation book. So once we meet, I will be checking your observation notebooks. Don't write here and there in the theory notebooks or like that. Buy a special notebook for your practical observation. Okay, so write down this experiment neatly, and next video I will be doing the second experiment. Kindly wait for it and watch it. If you like the explanation, give a thumbs up. Don't forget it. Okay, thank you.